These are sex-linked traits. For this type of genetic cross, we are going to look at traits where the genes are located on the X chromosome. The reason why this becomes a little bit more interesting is the fact that males will only end up with one gene for these traits, since males only have one X. So because of this, as we look at these traits, we will also be looking at the gender of the people that we are looking at. One such trait is whether or not you are colorblind. Colorblindness is a sex-linked recessive disorder. That means as we make the key, there are 3 separate chromosomes that can get passed on. There can be X big B, which would code for normal vision. Because remember, colorblind is recessive. There could be X little b, which would be a colorblind gene, or we could pass on the Y. Now, a normal female could have either X big B, or she could be X big B, X little b. A colorblind female is going to have to be X little b, X little b. A normal male is going to be X big B, Y, and a colorblind male is going to be X little b, Y. Now, males are going to have a greater probability of ending up with sex-linked recessive disorders because of the fact they only need to get one little b in order to show the trait. The reason for that is that their Y chromosome does not contain a gene for these types of traits. Let's look at a practice example. In this case, we want to cross a normal heterozygous female. She would be X big B because she's normal, X little b because she's heterozygous, and we're crossing that with a colorblind male. He would have to be X little b, Y. When we write out the Punnett square, we have to keep the X's together with whichever gene they're carrying. So this would be X big B, X little b for the female, X little b, Y for the male. Then we'd go through X big B, X little b, X little b, X little b, X big B, Y, X little b, Y. Now what we're going to notice is we've ended up with 4 different genotypes. We have to pay special attention to when there's XX versus XY because that's going to be male versus female. So when we look at our genotypic ratio, we are going to see that we have 1 X big B, X little b, to 1 X little b, X little b, to 1 X big B, Y, to 1 X little b, Y. Phenotypically speaking, we're also going to see 4 different phenotypes. We would have 1 normal female to 1 colorblind female to 1 normal male to 1 colorblind male. As you go through these problems, you are going to see that you have to differentiate between females and males. We'd also talk about probability. This one would be a 25% chance of a normal female, 25% chance of a colorblind female, 25% chance of a normal male, and 25% chance of a colorblind male. We get that from saying I had 1 chance out of 4 for each one of these to be happening.